square root from tables, and we need to understand that tables of square roots are used in a similar way to tables of squares. Square roots of numbers from 1.0 all the way to 99.9 are given in the tables and can be read directly and you will get the square root. And I want us to just look at an example. The square root of 1.86. How do we get the square root of such a number? To read the square root of 1.86, look for 1.8 in the column headed X. And then once you have 1.8, move to the right along this row to where it intersects with the column headed 6. There's a column in that table headed X. You will look for 1.8. And then you will walk to the right along that row until you will meet a column headed 6. So whatever is here at the point of intersection, there is this column and there is this row. That is the square root, and it is basically 1.364. What about that is the square root of 1.86? What about the square root of 42.57? 42.57. What do we do? In this case, there is a column named labeled X or headed X. Look for 42. You look for 42. Now not 4.2, 42. Because we are understanding that the square root of numbers in the table are given from the square root of 1 all the way to the square root of 9.99. So we are going to find 42 in the column headed X, and again move to the right. Along that row to where it intersects with the column headed 5. There's a 5 here. There is this number. We are going to read the number in this position, which is 6.519. But you see, we were looking for the square root of 42.57. What about, we have gotten 42, we have taken care of 5. What about the 7? What we should do, the difference for 7 from the difference column um, um, along this row is 6. You will find the difference column in that table, and within the difference column there is the column that is headed 7, and then you realize there is a 6 there in that table. Then what should we do? We should just add it to this. So plus 0.006, and this is 0. You add there 0.006, and then 5, and then 2, 5, and then the final submission is 6.525. 6.525. That is the square root of 42.57. Moving forward, how about the square root of 359, for example? Yeah, exercise. The square root of 359. In this case, and we should be very careful about this, in this case, we should write this one, which is 359. We cannot get a direct square root of this number from the table. So what should we do? Remember, the table gives us the square root of numbers between 1 to 99.99. So we should be clever enough to write 359 in any number between these limits, in any number between 1 to 99.9, we can easily have it like 3.59 times 10 raised to power 2. And this is the best approach, times 10 raised to power 2, and then the square root of this number. I want to teach something here. The moment we have 10 raised to power 2 here is a way that ensures that we are simply going to get a direct square root of 10 squared, because a direct square root of 10 squared is just this index divided by 2, because 10 squared is 100. So a direct square root of 100 is 10, which is actually 10 raised to power 1. So by all means, if you want to get the square root of numbers, make sure when you write it in numbers between 1 and 99.99, you will have to write it in such a way that it is multiplied by 10 raised to power even number. Because if we have 10 raised to power 3, then it's going to give us some problems in realizing the square root of 10 raised to power 3, which is basically the square root of 1,000, and it is not very automatic. So in this case, just get the square root of 3.59 from the table, which is 1.895, and then the square root of 10 squared, which is simply 10 raised to power 1. And the entire square root of 359 is 18.95, and that is it. What about the square root of 0.8236? What about the square root of this? Now, this one is less than 1. And again, we should write it in such a way that it is between 1 and 99.9. And raise it, multiply by 10, raised to power even number. If you write it, we can easily write this one 8.236 times 10 raised to power negative 1. And 1 is not an even number, so it's not going to be favorable for us. Or we can write it in terms of 82.36 times 10 raised to power minus 2. And this is now what we are looking for the square root for. Because 2 is an even number, we directly go to the table, get the square root of 82.36, which is 9.072, and get the square root of 10 raised to power negative 2, which is simply 10 raised to power negative 1, because we just need to divide the index by 2. So times 10 raised to power negative 1. And this negative 1 dictates that our decimal point will go to the left one step. And the square root of 0.8236 is 0.9076. And that is just like it. So try to get the square root, try to evaluate the square of 1, 25.6, and 2, 0.832, the squares of those numbers, and then the square roots of 1, 783, and 2, 0.07892. Try to just use the approach we have learned to get the square root of these numbers. Thank you so much.